We're living on a disk, floating through space, with a tiny sun.
Hey, I'm FTFE, welcome back to the channel that does to stupidity what the Wachowski sisters just did to their career with the launch of Matrix 4. Apparently, it's one of the worst movies ever made. That should be fun. Anyway, welcome back. Merry Christmas to all you wonderful people coming for what is sure to be a intellectual discussion loved by millions of people. It's going to hurt your brains, guys. I'm sorry about this. Tonight, we are debating somebody who is kind of important to the channel because he was the first flat earther that I ever debated in a debate that when I go back and watch I nearly cry because it's so cringy, and he was the first flat earther who got an episode of Flerfs Are Idiots, which I'm going to be doing a remaster of, so look forward to that. So let him introduce himself. It is Flat Out Hero. Flat, how you doing? Welcome back to the channel.
What's up? How you doing?
Doing very good. Just want to make sure you're nice and close to the mic and speak up a little bit for us.
Alright, can you hear me now?
Yeah, that's better. For those who haven't met you before, would you like to just take a couple of minutes and introduce yourself and tell everyone what you're all about?
I am Flat Out Hero. I'm all about telling everybody to look at what is going on around them, to test the things that you hear from NASA, and to definitely test and see if you can find curvature, see if you live on a ball. That's all I'm here to do.
Right, cool. Test to see if we can find curvature. There's been lots of that. Right, so you are a flat earther. You think the Earth is flat and stationary. I don't want to straw man you. Is that correct?
No, that's correct.
Right, so what would you say is your best bit of evidence for the Earth being flat and stationary?
Well, I mean, the best bit of evidence would probably be the railgun. Which the Navy has only recently began, the railgun, because the Navy's only recently in the past, I think maybe since 2017, started to try to pull it off of their off of their funding, because they realized their mistake when they started putting out all their showing that a railgun could hit a target and there's over 200 nautical miles away, and it's a line of sight target, and it's also the railgun doesn't shoot in an arc, it goes straight. So I mean, if you can go 200 miles in a straight line and like start at 15 feet and go and end 15 feet above sea level, that's kind of a little bit of a red flag, I think.
Do you have any evidence that would suggest that railguns don't fire in an arc, that would go against all of the operation manuals for the railguns that say that they fire in an arc and use gravity for what they do?
Look up
the actual manuals from the military say that railguns fire in an arc. I'm just trying to get that.
Yeah, no, I get it. They've recently started saying that they've got GPS guided projectiles and all that. But if you look at anything that they're publishing in like 2013 and stuff, when they were really bragging about it, they straight up say that they have just a piece of metal that is charged by two electric bars, and it goes straight down the railgun down the track, and it goes, what was it, like 7 times the speed of sound, Mach 7. And if you're a mathematician, right? You like math? Go ahead and do the math on that and see how far Mach 7 is going to travel in a straight line before it does an arc. Go ahead and you can.
So I'm just going to debunk what you're saying. If you just give me 1 sec, I'll bring up the screen here.
Sure.
Because you're wrong.
From 2013.
Very wrong. As is standard fare for a flat earther. So here we have.
Is this from 2017 or?
Hold on. Let me finish. This is from Naval Railgun Tech Assessment, U.S. Navy 2004, and shows how the railgun fires in an arc. And I'm going to read it to you here. This chart outlines some of the major advantages of the naval railgun. Significant are the very short 6-minute time of flight, the continuous availability of railgun fires regardless of weather, the difficulty of targets defeating the kinetic energy projectile, and increased lethality of the projectile itself. The airspace deflection issue, a major operational concern with both conventional guns and missiles, is virtually eliminated. Long-range conventional guns, rockets and missiles transit through airspace that must be cleared of aircraft. Along its entire path from launch to impact, the railgun's projectile spends only a very short time in its unusable airspace. Immediately after launch and just prior to impact, railguns pose only a trivial airspace management requirement compared to their alternatives. Similarly, the sensitivity to jamming of the GPS guidance unit, this is 2004, the GPS guidance, wait, let me finish. The GPS guidance unit with its rear-facing antenna is much reduced during the terminal position of its flight. Terminal position of its flight is when it's coming back down from the arc. Launch dynamics and lethality of the kinetic energy projectile are issues that the study panel proposes be addressed early in the development presentation. And here we have Naval Railgun FAQ and primers showing how they fire in an arc and use gravity to actually impact their target. So I am going to repeat, you are wrong. Railguns do not fire straight, they fire in an arc.
Do you see how that arc is going up above the land? You see that?
I saw how the arc went up and back down because it does not fire in a straight line. Yes.
But now think about this. If you were to shoot a projectile straight 15 feet above, parallel to the water, straight 15 feet above it, and then your projectile, how far is it going to travel before it starts to arc or sink? How far will it travel?
Instantly. If you fire something perfectly, let me answer your question. You've asked the question. Let me answer it. If you fire something perfectly straightforward, it instantly starts to go towards the ground. You can fire a bullet from a gun that is the same height of something that you're dropping, right? And both of them will actually hit the ground at the same time. The bullet that's fired from the gun and the thing that you've dropped. Obviously, the bullet from the gun will be off in the distance, but they will both hit the ground at the same time because gravity acts all of the time.
Okay.
But your claim. Let me clarify. Your claim was that railguns show that is the best proof that you have that the Earth is flat and non-rotating because they fire in a straight line. You are wrong. They use an arc that they fire in and require gravity to kinetically impact their targets.
They line of sight target.
It's not line of sight target. It is not a line of sight target. That is completely false. You will never ever find anything in
the other part of it.
You will never. No. Let me be clear. You will
200 miles across the ocean.
All right, carry on. Sorry. Right.
That was all I had to say. You can see 200 miles across the ocean.
Yeah, but railguns are not line of sight. They use
are
GPS.
They were.
I've just shown you from military manuals that it is not. Are you going to argue with the people that make and use them?
Wikipedia. Railgun, just like it.
Yeah, I'm not going to use Wikipedia. I'm going to use the military manuals.
Okay. Well, you're using a military manual that goes against what other things that they have published. So I don't know.
All right, present me evidence that they have ever published something that says it is a straight line of sight target, because you won't ever find it. I have just proven that you are wrong by showing you a military manual from 2004. I'm currently talking. I'm currently talking from 2004. Right.
How does a straight metal projectile go over the curvature of the Earth? How does that happen? Think about
because it fires in an arc.
No, you saw the diagram. Your proof right there.
Do you want me to bring it back up?
Do you want me to bring it back up? Over to aim it up. They have to aim it up above. They don't aim it up when they're firing for the line of sight target. They aim it straight at it.
But they don't. Yeah. Have you got any evidence for that? Because this shows how it is fired. See that there?
Yeah.
Ballistic trajectory, GPS, guidance, navigation, and control. Right. Let's go down. We can actually go to the world record
railgun shot. How about that?
Yeah, line of sight is not absolutely. Nowhere here. I've gone through it all, and I've put the link to this. Nowhere in the table of contents from this does it mention line of sight, straight line targets, because that is not how railguns work. Railguns fire in an arc to impact their target, as shown here by the ONR. These are the people that actually make it. The electromagnetic railgun shows how the direct fire from the horizon, the 6 seconds, ballistic trajectory, then GPS guidance in an arc. And then it shows here with the launch dynamics showing you when it fires and goes up in an arc. So unless you can present me with evidence that will counter what the actual military are saying, you are wrong and you cannot claim that I am. So that's your best evidence. Not very good, is it? Hello? Have you disappeared? You appear to be muted. Why did you mute yourself? Yeah, we can hear you. You appear to have muted yourself there.
I did. But yeah, no, you're not showing what I'm saying, but like I'm saying you can. How about this? How about
your claim was that railguns fire straight line of sight target, right? But they do not. You are categorically wrong.
You can tell by the Mach 7 for how long it travels, for how far it travels, which they've got a video of it going straight across. You can watch the projectile in flight not going in an arc. How about that?
Can you show me that? Can you show it not show?
Here, search this on YouTube. Railgun projectile in flight and see if it arcs. Go for it.
Railgun projectile in flight. You want me to go and search for your evidence for you?
I want you. Yes, you chose one of yours, and that's all I'm asking. Yeah.
No, but I have just shown you evidence from the military that you are wrong. Are you going to ignore the evidence that I have presented and still claim that you're right?
I'm trying to show you my evidence, and then we can decide. How about that?
But you haven't got any evidence. You've just made a claim and didn't bring evidence to back up your claim.
Wait, because
railgun in flight.
I can't even show my video right now. Of course I can't. But yeah,
okay,
railgun.
Right.
So
they've got a 3-minute video here, demonstrating the kinetic power of a railgun, where they are doing it on a small scale. So let me get this up so people can see. Right?
Not arcing. How about that? Right. It shows it not arcing.
This video.
There it was. No, I'm just kidding.
US Navy railgun projectile, how it was filmed in flight. They are filming over a very short distance in this testing facility. This is not... will you let me talk before you start? Okay. Let me finish before you carry on, okay? They are in a testing facility testing the kinetic impact abilities of the projectile. This is not how it works when they are firing it out at sea, as the documents that I've just shown you specifically demonstrate. This was specifically set up so that they could record it in a small scale, short range,
because it
safe
demonstrates
measure.
The long range. It demonstrates the scaled up long range. That's why they did that.
But I have just shown you military manuals. I have just shown you military manuals.
If it was going to arc on the short range, then it could show in the long range. But if it's gonna
firing it over such a short,
they wouldn't do a test run where it doesn't arc if it did arc.
They're showing it over. Are you going to let me talk?
Huh?
They're showing it over such a short distance that it doesn't need to arc. It's literally a couple of hundred. Are you going to every time I talk? Are you just going to interrupt me?
Well, no, I'm having a conversation with you. You're saying
no. The conversation works when one person speaks and the other person shuts up, all right? So let me finish what I'm saying before you try and interrupt, okay? The short distance... and once again, you start talking the second I start talking. Please wait until I've finished. Is that all right? Please wait until I've finished. Thank you. The short distance of this film, set up specifically to be able to record it in flight, has such a short flight distance that it does not even need to arc. However, there will be a very small arc that matches the curve of the Earth because of gravity. Now,
well, that would be in what?
As I have shown with the military manuals, when actually firing upon a target over a distance, they do not fire in a straight line, they fire in an arc. They only ever fire in a straight line for short-range kinetic testing. Is that clear?
Figure it out. It's going Mach 7. If it's fired from...
Yeah, cool. That makes no difference to firing in an arc.
Wait, you're interrupting me now. I thought you said don't do that. Can I have a chance, please?
Right, yeah, okay, so right, it's traveling Mach 7.
Can I have a chance or no?
Yeah,
is that not
yeah, carry on. It's traveling Mach 7.
You gotta stop that.
Yeah, I'm just asking you to carry on. Yeah.
Again. Ready?
Yeah, I'm waiting for you to carry on, yeah.
Fulfill me. All right, if you're going Mach 7 parallel to the ocean or parallel to any body of water that's flat, you're going to have what is that? That's 6,000 times 7. Shit, this was like 30. It's about, I don't know, 28,000 miles per hour. If you put that down to what, divided by 60, so you'd hit curvature, or you'd start going up above the.
Why would you hit the curvature?
Well, you'd go above the curvature at, 1 mile you'd be above 8 inches. 7 miles you'd be about like 36 feet. They don't, their test demonstration does not show that it would do that. And they can hit something 200 nautical miles away, without having any guidance to it.
No, they do have guidance. I've shown you they have GPS guidance from at least 2004.
No, that didn't say it had GPS guidance.
Do you want me to go back to it and show you again? Because you obviously weren't paying attention.
Yeah.
Right, so this is from 2004 again. This is the... oh, I'm not actually showing it, so sorry, my bad. Display 1. This is from 2004, the EM Railgun game-changing, the ONR presentation, Naval Railgun Tech Assessment from 2004. And as it says here, when it follows the trajectory, it starts with its ballistic trajectory. When it reaches 500,000 feet, it goes to GPS, guidance, navigation, and control. So at least from 2004, they were using GPS, guidance, navigation, and control.
Tell me when it's my turn.
I've finished talking.
Okay, so now look. Go ahead and put on right there in that search bar, type, what is a railgun projectile made of?
And what does the composition of it mean?
Yes. Yeah.
What does that mean? How does the composition...
well, if it's a piece of metal,
the military
if it's just with no electronics on it, then that GPS doesn't fly. It doesn't work. There's no
right, so you're claiming it's not GPS, even though it says it's GPS.
That one, I think I said that whole thing.
Here we go.
Compared to everything else.
Let's bring this up. Yeah. So here we go. It's
no.
That doesn't really show
anything before 2017.
Right. So Daily Mail.
Right. See that fireball video? See that fireball video? Click on that.
Yeah. I mean, it all talks about having stuff on the. It all talks about having stuff on the inside. But again, I'm going to just cite the military documents that says it uses GPS.
2013. You're showing
you interrupted me. You're interrupting me. This is from 2004. 2004. Is 2004 before 2017? Yes or no? I'm asking you a direct question. Is 2004 before 2017? You need to stop talking so you can listen to me. Is 2004 before 2017? Yes or no?
Yep, 2004.
Right, exactly. So this is from 2004, and it says it uses GPS. We have now covered that. You are wrong. Do you have any other evidence?
If I write something online and say it's from 2004, does that mean it's 2004?
The document actually comes from 2004. You can go and look at it yourself.
I could make that on my computer, literally.
I'm sure you could. Claiming it's fake doesn't matter. That is finished. We are going to go on to the next subject.
Yeah, I bet it is.
Yeah, because I've shown that you are wrong.
Okay. Well, anybody that wants to
now we go to the next subject.
What projectiles? What they said that they were made out of in 2013.
Yeah, in 2004 they used GPS. So unless they regressed the technology and decided to use less effective technology in 2017, you are wrong. So how about we talk about the two videos that you've done against me recently?
Let's.
Right. So, well, actually, one wasn't specifically against me, but it was your first Flat Earth video in a while. Where you claimed that the sun is a burning ball of gas in a vacuum that needs oxygen. Do you want to explain that?
Do I want to explain why an explosion or fire needs oxygen? Or a continuous source of oxygen?
Just explain your entire thought process behind your issues with the sun.
Okay. Well, any type of explosion or fire that we can recreate ourselves, that we can actually test and see. Fusion, we can't test that. We can't do that. That's not, me and you cannot do that. So anything that we can test that fire is going to need oxygen, right?
Okay, but
Right?
what's fire or explosions got to do with the sun?
Well, because it's a burning ball of gas, right?
No, it's not.
Well, the sun has been taught to us in school that it's a burning ball of gas.
No,
Hydrogen.
it wasn't.
Yeah.
I don't know what school you went to, but if it taught you that, it was a shit school, because the sun is not gas and it is not on fire.
It's not hydrogen? It's not hydrogen.
It's mostly hydrogen, but it's not on fire.
That's a what?
It's not mostly hydrogen. It's about 1.2% oxygen, actually, interestingly. But it is not on... Let me be clear here. Let me be clear. It is not gas, and it is not on fire.
What is hydrogen?
Hydrogen is an atom. An element.
Okay. Is hydrogen a gas?
Hydrogen 1, in its base form, is a gas. Not all hydrogen is a gas, no.
It's not,
you can have metallic hydrogen, you can have liquid hydrogen, but the sun is mostly plasma.
Wait, but I thought you said it was mostly hydrogen.
Yes, mostly plasma, yeah.
Well, okay, so plasma and hydrogen are the same thing on the sun, but they're not the same thing here?
Plasma is a state of matter. The sun is
of
mostly plasma of hydrogen.
Okay, I get this now. Can you recreate hydrogen and plasma on Earth?
Yes, it's been done in the lab several times.
Can you show it?
Do you know what plasma is?
No, I'm not. I know that it's a super hot element that you can make in like microwave grapes. Is about as much as I know about plasma.
Yeah, that's quite fun actually. But it's an atom that's been ionized. It's had its electrons ripped away, removed, right? So it's got an electrical charge.
So now
it is hydrogen, right? But it is a state of matter called plasma that is hydrogen. There is no gas on the sun, and the sun is not on fire.
So when did they first start pulling away the electrons and protons from atoms? Was that before or after they could actually see one?
That's always been going on as long as there's been plasma in the universe.
Okay, sure. So they've been pulling neutrons and electrons. What kind of
question was that? Sorry, ask that question again.
Yeah. Okay. How did they pull neutrons and electrons or protons or whatever out of
who said anyone pulled protons or neutrons away? I said specifically electrons.
Okay, electrons. How did they do that when they couldn't even see it?
We didn't do anything to the sun. The sun exists without us having anything to do with it.
I said that you said we pulled electrons out of the atom, right? How did they pull electrons out of something they couldn't see?
Who?
And how do they know they did it?
How did who did it?
Whoever did it. I don't know. You're the one that said they did it. I don't know.
Who?
You said
yeah,
they
we can see the atoms. We can see atoms. We can image atoms. We can see what's going on with atoms. We can split the atom. Hence, we have nuclear power.
The first picture of an atom has been recorded about 10 times.
Yeah,
and
you can tell when you've got a state of matter by its physical properties. We know that energy transfers in a certain way, and we know that when you remove electrons or add electrons to an element, it gains a charge and becomes ionized. I mean, Nikola Tesla did experiments on plasma, quite a lot of experiments on plasma back in his day. They've known how to
did he ever manipulate how to take electrons out of an atom?
Yeah, it was a lot of his work was based around plasma, actually. We know how to manipulate atoms, and we know what different states of matter are. But none of that is relevant. It's really hard to have a conversation with you if you just keep talking whilst I'm talking.
You're not stopping at the points I need to make. You're not stopping.
Let me finish what I'm saying, and then you can continue. All right? So we know what plasma is, and the sun is plasma. It is not a burning ball of gas, so your entire nonsense is null and void because you have strawmanned what the sun is.
Okay, well, here. You have been saying that they can do things that you have no idea that they're how they did it or what they are, like the electrons being pulled out of atoms. When how in the world did you ever how did you ever pull something out of something you couldn't see? And second of all, if you're talking about the sun and the moon are the same shape, the same size, and they're both come above us, the same pattern.
Size. Huh? The same angular size, but not the same size.
Okay, well, whatever, they look the same to us, to our eyes. What we can see, what you and I can verify, they're the same size. So if you can see, like when you look outside at night, can you see the craters on the moon with your bare eyes?
Not the full craters. No, you can see the surrounding areas around it. But let me ask you a question. Which one of these is bigger? Which one of these is?
I was going somewhere with that. See how you want?
Let me ask you a question. Let me ask you a question. Let me ask you a question. Which one of these is? Which one of these is bigger?
Play it fair, bro.
Which one of these is bigger? Which one of these is bigger?
Mute yourself, bro.
Which one of these is bigger?
Mute yourself, bro.
Yeah, answer the question. Which one of these is bigger?
If you're not going to let me talk, we're not going to get anywhere.
You asked me a question about seeing craters on the moon, and you also talked about the sun and the moon appearing the same size. So I'm now responding to that. Okay?
No, that's not the point, though. That's not the point.
So you said that for no reason.
You're trying to go away from the point because I'm trying to tell you something.
Right. Okay. Get to your point then.
You can see detail on the moon with your bare eyes. Correct. You verified it.
You can see shapes, roughly, yes.
You can't see the flag on the moon, or you can't see the rover, but you can see craters, right?
You can see certain shapes. You can't make out individual craters, really.
Okay. Well, I mean, yeah, you can. You can.
Not really. You can't really make out the detail with your naked eye, no.
Yes, you can.
No, you literally can't make out the detail of like individual craters on the moon.
You can see their shadows on the moon.
You need a bit of magnification to do it.
There's shady parts you can see with your bare eye. How about that? You
can
see
that's
the face
not
in
craters.
The moon, right?
That's just shady parts.
I can see the face in the moon. The face in the moon, that works, right?
Yeah.
You can agree on that?
Shape of the moon, yeah.
So,
you can see the entire moon, you're right, yes.
Well, if you can see the face in the moon, when if at that detail when mountain ranges, like you look at a mountain range on Earth that's compared to the moon. The moon's super small compared to Earth. Like it's
1/6 the size.
Huh?
It's 1/6 the size.
Exactly. It's way smaller than Earth.
Not that
Those
much
mountain
smaller.
ranges on there. What?
Not that much smaller.
Well, it's
like 1/6 the size. I mean, that's still pretty damn big.
Well, I mean, okay, it's big, but it's not as big as the Earth, right?
Correct. Yeah, so that's why it's a moon.
So now Earth's mountain ranges are way bigger than anything that's on the moon, right?
There is some geological features on the moon that are almost as big as some on the Earth.
The Appalachians. Is there anything that could possibly compare to that?
I'm not sure of the exact specifications, but what's your point? We're going back to the very first debate we had, which is interesting.
Probably, but what's really interesting is when you're looking from the ISS without using any of their zooms, when they've got their camera looking down on Earth as they're going super slow across their orbit, you can't make out that much detail. And
I've seen some pretty spectacular pictures that would disagree with that.
Well, look at the ISS right now. It's going over water. You cannot even make out any land. So the live
right
ISS
second it's going over water. Is that, are you sure about that?
It's always going over water. Always going over water. Like there might be some like vague land under the clouds here and there, but generally 99% of the time it's going over water.
The Earth's surface is like over 70% water, correct? But anyway, what's your point here?
Okay, well, think about this. If you're only 250 to 300 miles high, and you're looking at the Earth, which has huge mountains, and you can barely make them out because they're that much of a blur with no cloud cover or anything like that. How is it from only 250 miles? Then you go 100 times that. Wait, no, that's 100, almost 100,000 times that. 250,000. That's exactly that. 250,000. It's 100,000 times more of a distance, but you're able to see more detail on the moon than you are from the ISS.
I disagree that you're able to see more detail on the moon. To see detail on the moon, you need to have magnification.
See the live feed.
Yeah. So let me kind of clarify this for you. So the ISS, when looking at the Earth, can only see about between 2 and 4% of the Earth's surface. All right, it's not very much. So they're actually relatively close and can make out quite a lot of details. The moon, 1/6 the Earth's size, a 250,000 miles away, you can't make out any detail on the moon. You can just see shapes and some shadows and stuff. You cannot make out any detail on the moon with your bare eyes. You need magnification to actually be able to see the craters. So your entire point is null and void because you have no evidence for what you claim. It's just claims.
You agreed we could see the face, so you can see detail.
You can see the entire face of the moon, yes, not the individual details of craters or mountains.
Face, the two eyes and the mouth, you can see that.
Oh, no, I don't mean that you can... see. I mean, you can see the entire face of the moon.
Everybody in history, including you tonight, when you go look at it, can see the face of the moon.
Yeah,
everybody. They see the face of the moon.
That's not detail. That's just random shapes. You cannot make. Let me be clear. Let me be clear. Don't let me finish. Don't let me finish. You cannot make out any individual craters or mountains on the moon with your naked eyes. You can see vague shapes from geological features that are very far away, but you cannot, categorically cannot make out any detail on the moon without some kind of magnification.
My turn?
Yeah.
Okay.
Please now, respond directly to what I've just said, though.
When you zoom in on the face of the moon, when you zoom in on those dark circles and the eyes and the mouth, what are those? Those are craters.
When you zoom in, yes.
Vague geological shapes. Hold on. It's not vague geological shapes. Those are craters you're looking at with your bare eyes. So, once again, we're able to see craters from 250,000 miles away.
No, we're not able to see craters. I told you that. You cannot see craters on the moon.
Zoom in on its crater. Zoom in on it. That eye.
Yeah, but you can't make out the crater unless you zoom in.
The what?
You cannot make out the crater unless you zoom in. And just because it's too far away to... you asked me to respond, so let me finish. Just because you can make out vague details doesn't mean that you can see the actual,
you zoom in strong.
Once you zoom in, yes. But that's the thing. Just because you zoom away from something doesn't mean it magically disappears. It just means that you can't resolve the detail anymore. We see what we expect to see on the moon. If you're going to make this claim, right, I would expect you to come with an angular resolution, breakdown of what we should and shouldn't be able to see. Can you present me, I'm asking the question here, can you present me any maths or any experiments that could back up your claim that we see too much detail on the moon with our naked eyes?
Sure, fucking YouTube.
No, YouTube isn't anything scientific.
YouTube video of the moon, that's all you got to YouTube, and they're going to show it to you, unzoomed, no zoom video of the moon.
Yeah, no zoom, you can't make out detail. Zoom in, you can make out detail.
Huh?
Zoom in, you can make out detail. Zoom out, you cannot make out detail.
Well, go ahead. Let's see it. YouTube it. Let's see.
Zoom in, you can see detail. Zoom out with your naked... And anyway, we're not talking about a camera. We're talking about with the naked eye, which was your claim. With your naked eye, you cannot make out detail on the moon. Next claim, please. We've done that now. I'm not going around in circles with you. You've so far brought two bunk claims. How about we go to one of my claims?
So are you just going to claim victory when
yeah, because you're absolutely wrong. You're making stuff up with nothing to back it up. You cannot categorically make out details of mountain ranges and craters on the moon with your naked eyes. It is not possible.
Okay. I'll go on to this one. This is a real easy one for you to understand. Actually, I already made a video about it. How about that?
ISS. Yeah. Do you want to do the maths for that?
No, I want you to show me, like I asked in the video, of any other time that you can see something smaller from closer or from farther away than you can see something that's much larger.
Yeah, that doesn't happen. That bunch of sounds you just made. We're going to do the maths. We're going to do the maths, right? We're going to do the maths. We're going to do.
It doesn't happen.
We're going to do the maths, and you're going to be quiet and learn something. So, to find out the angular diameter of something, there's a specific formula. Okay, it is alpha equals 2 times arctan of g over 2r.
This is why you have to do these things. You cannot simply show it happening.
I'm trying to answer. Are you gonna? I'm answering your question. I am answering your question. Let me answer your question, and then you can come back with problems. Okay?
I did an example.
Right, so
it was what it was.
So we're going with your example of the ISS. So please just listen to my response.
Point to me.
Can you listen to my response, or are you just going to babble?
Show me an example.
Are you going to listen to my response, or are you just going to babble? Right, I'm going to carry on my response. Right, so to find out the angular diameter of something, for instance, the ISS, you use this formula. Alpha equals 2 times the arctan of g over 2r. Well, alpha is the angular diameter of the object, g is the actual size of the object, and r is the distance to the object. All right, so we're going to plug in the numbers here. So alpha equals 2 times arctan, and g is the actual size of the ISS, which is 72 meters. We're going to do this in kilometers. So 0.072, and then you'll divide that by 2r, And the distance
But-
to
but-
distance
but-
to
but-
I'm but
It's not a dimension.
I'm talking
72 meters. That's only how long it is. That's not a dimension. What's the rest of it?
angular diameter.
No, 72 meters by what?
We're
By what?
doing it 72 meters across.
Okay, 72
Right.
meters by what? By what?
Well, it doesn't matter because we're getting the angular diameter. Right?
That's not showing the size of anything. That's showing the length of something.
All right, and
that's
the,
not-
the,
that's
it's,
not
it's
gonna give you anything
I'm
in
counting.
reality. So
Right,
why
listen.
don't you-
Stop talking and fucking listen. I'm counting the ISS as roughly circular. Okay, it is roughly the size of a football field. Okay, about 72 meters in diameter. So that's what we're going with because that's really quite close. Right. So
fine,
and then
okay.
let me fucking finish. Shut up and let me finish.
okay.
Shut up and let me
Fine,
finish.
fine.
Right.
Fine.
R is 408 kilometers. So 2 times 408. All right. So this is what we got to do. So when we plug in these numbers, what we get is an angular size of 0.01 degrees. Right. That is
I
the
guess.
angular
Sure.
size of the ISS at the height it is with the size it is. Now, let me show you a citation.
So your calculation said that you should see something 72 meters across.
No,
from,
no,
250,000?
I've not said that. All I've said is the angular size is 0.01 degrees. All right, that is what I've said so far. Now pay attention and let me finish.
That's the size of it that you came up because angular
Let me.
size. How?
Will you?
To what?
Let me finish.
You're not. Go
Let
ahead.
me finish.
Go ahead.
Right.
Go ahead.
According to sciencefocus.com, at absolute best, humans can resolve two lines about 0.01 degrees apart. Now, if at absolute best, human eyes, without any aid at all, can resolve two lines about 0.01 degrees apart, and the angular size of the ISS, according to the maths, is 0.01 degrees, would our eyes be capable of seeing the ISS unaided, yes or no?
No, because look, if you
The
said
maths
it's the size of a
disagrees
football
with you,
field. Hold on.
and in science,
Hold on.
maths is proof.
Okay, well, let's see. Now, the size of a football field, correct?
Yes.
That's what you said? Okay, size of a football field. I think the football field's 300 feet, but whatever. Let's go with football stadium like I did in my video, which you so already have understood. A football stadium from 1,000 feet high is able to be seen at pretty real small in the camera without any optics. Now you go 2,000 feet. I can't find a picture of a football stadium from 2,000 feet. Maybe you could. Maybe you can.
Maybe no one's
Maybe you
taken a
might.
picture of a football
You
field
cannot
from 2,000
You
feet.
cannot see a football. Wait, you can't see a football stadium from a mile high. You can't see a football stadium from an airplane. You can't do that. But you're trying
Okay,
to say
well,
you can see.
have you done the angular size calculations to be able to see what you should be able to see?
I've seen it with my eyes. I've seen it with my eyes.
Okay,
Your
so,
angular calculation is wrong because you're trying to tell me that you can see a football field from 250,000 miles away. Well, you can't see it from a mile. So,
well, now let me be clear, all right? At 0.01 degrees, let me be clear. At 0.01 degrees of angular resolution, you are not going to be able to see.
In that size.
Amazing that you keep interrupting me when I'm trying to respond to your questions. So let me be clear. At 0.01 degrees of angular resolution, you are not going to be able to make out any details. It is going to be a tiny dot, but your eyes will be able to see it because it matches the angular resolution size of your eyes. Now, even if it was below the angular resolution size of the eyes, you can still make out the ISS most of the time because it ends up being a point source of light because sun reflecting off of the solar panels. Now, if you were looking at a football field from an aeroplane, you will not be able to make out the details of the football field, but you absolutely would be able to see the football field if you knew exactly where it was. It would be a dot. It would be barely be able to see, but you would be able. It doesn't instantly just disappear because it got smaller. But I have just done the maths for you live to show you what the angular resolution of the ISS is at the height that we say it is. And it matches the limitations of the human eyes. So seeing the ISS is no problem. I'm done. You can respond. Oh, he went away. You seem to have disappeared and then come back. That was all an explanation for nothing, I guess.
Sorry, I got a phone call and it kind of messed up the volume.
Jesus
I couldn't
Christ.
hear you.
Right. Anyway, angular size matches human eyes. No problem seeing ISS. You can see football field. It just be dot. That's a brief overview of what I just said. So
Okay, well,
we've covered your points. And
wait, hold on.
you are categorically wrong unless you can present me with some kind of scientific citation or evidence to, go against the claims that I have shown here today. Then we can move on to the next bit, which would be one of my points of evidence for the Earth being a rotating globe.
Rami?
Sorry?
Rami?
Rami?
Yep. Is that what your point is? Rami?
What does that mean?
Go ahead. What's your point?
I haven't made a point.
I know. What is it? I'm asking.
Well, right, so I am going to present evidence that the Earth rotates in 3 axes, which, if it does, it has to be a sphere.
How did you come up with that?
We measured it. Pretty simple, actually. Because if you can measure something, then it exists, right?
What was the tool used to measure it?
A pendulum.
A pendulum?
Yeah.
Okay.
Very simple. So, I'm surprised you've never seen this before. Did
they have to push it at the beginning?
Irrelevant.
If they have to push it at the beginning, if they have to start it to start it to get it to start
completely irrelevant
rotating,
to the entire point. So please don't strawman what I'm going to say before I've even said it. Okay.
Well, I'm just saying, if it's pushed or if it doesn't start on its own, then there's
it's not
obviously
supposed to
no
start
rotation.
on its own. That's not what we expect.
Well, yeah, it is what you expect. If it's going
No, it's not what we expect. It's not what would happen, and it's not what we expect. That's a straw man of my position.
Rotation, because it's going to alter its swing. Then it's obviously going to have enough movement to make it swing.
No, not at all. It maintains its motion relative to the Earth when it's still and hasn't had a swing put onto it. There's no reason in physics that a pendulum should start swinging on its own when it's just sitting on an Earth. That wouldn't happen because conservation of momentum is a thing. So do not strawman my position before I've even made it. Okay? We are not concentrating on the fact that it has to be started. That is not the effect that we are paying attention to. Right, so I am going to ask for you to be quiet for a few minutes while I explain my point. Is that possible?
Go for it. Yeah, go for it.
Right.
Yeah, I'll mute.
So, the gentleman physicist did an experiment to demonstrate the Earth's rotation. Foucault's pendulum is well known to show the rotation of the Earth. This is a famous Foucault's pendulum which has a magnetic motor to keep it going over the period of rotation due to Coriolis forces, goes around in its entire circle. So, what we do is we make some predictions. If the Earth is a rotating globe, then a swinging pendulum will have some effects on it, all right? And it's this pendulum swinging that is important. It doesn't matter that it's been started by a person. That's not the point. We don't expect it to start on its own. That's not what physics says would happen. But when it's swinging, we can look at the effects that happen to make some measurements. Now, if the Earth is rotating, Coriolis forces will affect the drift of the pendulum. Once the pendulum is swinging, as you can see, it's swinging backwards and forwards here. It goes through this ink tray and leaves a mark. And then over a period of about 40 minutes, let me get where it is. It keeps swinging for 40 minutes, and then when the inertia runs out because of gravity and friction, they measure the angle that they got, and it went for about 40 minutes, right? So the first prediction of a swinging pendulum is if it's in the northern hemisphere, in this case, it's going to have a clockwise drift. So straight away we've got a match with the prediction, all right? When it's swinging, when a freely moving object is going, it has Coriolis forces imparted onto it due to the fact the Earth is rotating. And it makes it go clockwise. In the southern hemisphere, it makes it go counterclockwise. So those are things that can't be explained if the Earth's flat and stationary. So what do we do? Well, first of all, we need to find the period of rotation for how long it would take to do an entire 360 degrees. So first thing we do is a bit of maths. So it swung for 6.88 hours. So you times that by 360 degrees divided by the drift amount that you got in degrees. And that is T, your period of rotation, which is 31.4 hours. Okay, and then you can do another bit of maths to actually use that information to calculate your latitude on Earth. So to calculate your latitude on Earth, you take the arc sine of 24 hours divided by your period of rotation, which in this case was 31.4 hours. And if you do this maths, anywhere on the Earth, you will get a number which is extremely close to your latitude on Earth, be it in the northern hemisphere or the southern hemisphere. The only place this isn't going to really make a difference is the equator, because there's no Coriolis forces imparted onto the swinging pendulum at the equator, as expected. So, to clarify, we are not talking about the fact that it had to be started. That is irrelevant. Physics doesn't say that it should start on its own. What's important is the drift induced when it is swinging backwards and forwards. That has to be explained if the Earth is flat and stationary, that it is predictable, and that you can use that to calculate your location on the Earth. So, are you able to give me an explanation for how this happens if the Earth is flat and stationary?
Well, when you push it, is there a machine pushing it, or is that a human pushing it?
That wasn't the question.
No, that was. I'm going somewhere with it. So now answer me. Is it a human pushing it?
In the experiment I just showed, he lit a lighter on a bit of string to release it so it could move, so it could swing backwards and forwards. But again, the question to you was, how does the flat Earth explain the drift induced on the swinging pendulum that matches your latitude on Earth and your hemisphere? How does the flat Earth explain that if we are not rotating? Because that matches the predictions of rotating.
Wait, so you're saying that if it goes around and it makes a full circle after, if it were to be swinging forever, if it could swing forever, you mean like if it was having any forces imparted upon it, like it were to swing forever instead of just swinging for a little bit? Because in order for something to affect it, it would have to be starting it. If it can affect it,
no, that's completely wrong.
No, if it affects it, you would see it move.
No, it's completely wrong. And you're avoiding the question. You're avoiding the question. The question is the question is, how does the flat, non-rotating Earth explain the drift induced onto a swinging pendulum?
I just said it doesn't fucking prove anything unless it starts by itself.
It shouldn't start on its own. You are strawmanning physics. That is not what we expect, and you are ignoring the question. The fact is that we can use the drift induced to calculate our latitude on Earth. How is that explained on a flat, non-rotating Earth?
Show me another force affecting something without it being able to start it in motion. Show me
that. The Coriolis force does that all the time.
No.
Centrifugal force doesn't start anything.
That's a theory force. Let's see.
What's a theory force?
Well, because it's obviously not a force that we can measure.
We can measure it.
No.
I've just shown you an experiment where they measured it.
No, that didn't measure it. And then
it absolutely did. It absolutely did, and it gave predictable results, which matches the hypothesis and prediction from it. Right? We verified our hypothesis of a rotating Earth by seeing the drift induced onto a swinging pendulum. And that is what we need to concentrate on. That drift induced. Why, if the Earth is flat and non-rotating, was there a drift induced on that swinging pendulum?
No idea. No idea what's going on with it. It doesn't have anything to do with the Earth being rotating.
It matches the predictions of a rotating Earth.
No, match, because the prediction would be that if it's a force that can affect it, it would start it.
No, that's you not understanding physics.
Well, show me where I'm wrong, please.
Centrifugal acceleration doesn't start things.
What?
Centrifugal force doesn't start things, yet you can still feel that when you're being pushed to the back of a tilt-a-whirl.
A motor, so an engine, a centrifugal engine. You cannot have that engine start without combusting something and making it start.
Yeah, but the fact the Earth is rotating It's already rotating. That's what imparts the force. You are ignoring the fact that we get... Right, no, let me explain again for your extremely limited intellect. We get predictable results. We expect to get the results of the drift induced onto the pendulum that matches our latitude on Earth. That is what we expect to happen if the Earth is rotating. We do not expect a pendulum to start swinging on its own because conservation of momentum and gravity are both things.
Well, are they? Really? Gravity?
Yes, absolutely. Gravity is 100% real. That's not really debatable.
Well, let's go on to that then. All right. So if I got a butterfly and I got it sitting underneath an elephant, is the elephant going to be able to be pulled down by the gravity?
Everything's being affected by gravity all the time.
Everything with mass, right? Right.
Yes.
That's the definition. Okay.
So wait, you're just moving on from the fact that you can't explain the pendulum.
I told you I had no idea. It doesn't impress me. There's nothing that says.
Well, again, it matches the predictions of a rotating globe. That is what we expect to happen. And if something that we expect to happen happens, you really don't know how to stop. If something that we expect to happen happens, what can we infer from that?
Well, I don't know how you could expect it to happen when
because that's what physics says should happen.
Not what's happening. If you expect something to affect something, then it's going to affect it.
It does affect it, and it affects these. The Coriolis force does not make things start, and you are strawmanning the Coriolis force by saying we expect it to make things. You are strawmanning the Coriolis force by saying we expect it to start movement in a linear fashion. Coriolis force does not do that. Coriolis force induces a force on something that is already moving. So what we are seeing in that pendulum is evidence that Coriolis force exists because the Earth rotates. If you cannot explain it with a flat non-rotating Earth, that means it is evidence that the Earth is not flat and non-rotating, and it is in fact evidence that the Earth is a rotating globe, because it matches the prediction of such.
You know, I'd be interested to see if you could take that experiment and do it in like a helicopter, or do it in something where you're not attached to the Earth.
Do it in a helicopter. What do you mean in a helicopter?
Oh, I mean, like, because you're getting the rotation of Earth. That's what you're inferring out of that, right? So
we're saying that Coriolis force is induced by the rotation of the Earth, or in effect, yes.
Okay, now, if you were to do it in a helicopter, or someplace that's not on the Earth, you know what I mean, like someplace that's helicopter,
you wouldn't be able to do it in a helicopter.
Well, I mean, you could if you were to do it inside of a big enough helicopter.
Yeah, you'd need a really big helicopter. But what you're doing right now is putting unrealistic expectations on science, which is a hallmark of pseudoscience.
I'm trying to fix the experiment because the experiment's flawed.
There's nothing wrong with the experiment. It's been repeated millions of times and gets the results we expect. Yes, just because you don't understand it doesn't mean it's invalid.
No, now look, here's what I do understand. You can't provide any other example of a force affecting something without it starting.
Centrifugal force, gravity.
Okay, that's not a force.
There is a force created by gravity. 100%, we can measure it.
If you want to call it a force, then great. So now, if you're going to say it's a force, does that mean it's a force like magnetism? Is that the kind
It's an apparent force in a reference frame, otherwise known as an inertial force, or a emergent force, or a fictitious force.
What does this affect specifically? Mass?
Everything with mass, yes. And
everything with mass.
Everything with or without mass, actually. Just everything in the universe.
Like helium?
Yes.
Okay, so then, and how is helium able to overcome gravity?
Do you know the equation for buoyancy?
It doesn't matter. I'm saying
it does matter. Do you know the equation for buoyancy? Yes or no?
Nope, don't know any equations.
Of course you don't. So the equation for buoyancy is FB, which is the force of buoyancy, equals rho, which is the density of the median, times g, which is the acceleration due to gravity, times v, which is the volume displaced. So buoyancy is a result of gravity. So when a helium balloon is going up, that's because gravity is pulling the more dense, heavier things around it down with more force because there's more mass, which creates a force in the opposite direction to gravity, forcing the thing less mass, less density, the opposite direction. Buoyancy, helium balloons and everything like that are a prediction of gravity.
Is gravity alive?
Of course not. That's dumb.
Okay, so then, well, I mean, it's picking and choosing how much force to apply on. How does it pick and choose how much force to apply?
Different mass means different force.
Okay, well now check it. Magnetism, it's a force. Wind, it's a force. Any other force that you can come up with, it does not pick and choose how much of itself to apply on anything.
Incorrect.
That's not how forces work.
Absolutely 100% incorrect. Are you telling me that if I had a extremely strong magnet and I decided to put this next to it and this next to it, they would both be pulled with equal force?
If they're both metal...
No, but they're not both metal, are they? So there will be different forces. And are you telling me that a lump of gold and an aluminium can will be pulled with the same force?
They won't be pulled at all.
Are you telling me that a ferrous iron and a copper coin will be pulled with the same force? Different materials have different magnetics. Right? There is different forces applied to different materials based on magnetism. There is different forces applied to things with different mass because of gravity.
I'm not applying. Now, you said it affects everything with mass.
Yes.
Magnets affect everything with steel, right? Now, put a 300-pound bowling ball 2 feet away from a 300-pound magnet that could right within its range, so it starts and it pulls it, and as it gets closer, it's going to pull it faster. Boom! It's going to pull it next to it.
Now, that would be a greater force than something with less.
That would be now. You put a paper. You put a paper clip 3 feet, the same exact distance as you put that 300-pound ball, and you put the paper clip right there. What's it going to do to the 300-pound magnet? Is it going to be able to withstand any forces, or is it going to slam up against it?
Right. So it's going to be exerting more of a force on the thing with more metal in it, which you would be able to tell by. You've asked me a question. Let me fucking answer. All right.
Okay. Yeah.
Fuck's sake. Right. So if you get a paper clip or a big metal ball, right, and put them the other side of your hand where the magnet is, the big metal ball will be creating more of a force towards the magnet than the little paper clip is.
No, it's more weight.
So you're wrong.
More weight, not more force. The force.
Weight is a force. Weight is a force. Weight is a force.
It's not the magnetism force. It's the force of weight.
Yeah, due to the extra force created by the magnetism, which is proportional to the amount of material. The same way that with gravity, more mass means more force, because the most basic physics equation that you have is F equals ma. Force equals mass times acceleration. Everything will accelerate at the same rate. That means that things with more mass have more force acting upon them.
Okay. Now
seriously,
look,
your ignorance of physics is not an argument against it.
Is it my turn yet?
Yeah, I'm just telling you that your ignorance of physics is not an argument against it.
Now look, if you have that magnet doing like you said, and only applying a little bit of force to the paperclip and applying way more force to the ball. I want you to say that's what you said, right?
Yeah.
That's
what happened. That's why if you have your hand and one side of the magnet and the ball and the paperclip the other side, the ball will have more of a force pulling you towards it than the paperclip would.
Okay, now here's where I say you're wrong, and you can tell me where I'm wrong. If you put that paperclip there, it's not going to travel. Listen, it's not going to travel the same speed that fucking ball went. That ball's going to go way slower, and it's going to get a little bit faster.
Yeah, because it needs more force. Yes, because it's bigger, so it needs more force.
Now look, that same force is being applied to the paperclip. That's why it slams up against it. It doesn't travel the same as the ball.
No,
it goes.
Force, like acceleration, is like a measure of resistance to movement, right? So force is. So, if you had enough time and distance, those things would end up traveling the same acceleration. They would go the same velocity eventually. However, because it needs more... Are you going to let me finish what I'm saying? Why is it you have the inability to shut up when I'm trying to respond to you?
Because you're not responding to me.
I'm literally trying to respond to you, but you keep opening your fucking mouth. Why is it you can't shut up now, but trying to talk to you over Hangout is like pulling fucking teeth?
Probably because I got a job, I got a life.
Yeah, so you can't look at your phone?
No, not.
Of course not. Of course not. So, there will be more force applied to the big metal ball to be able to get it going the same speed as the paperclip. More of it needs more force for the same acceleration to happen. right? That is physics.
Absolutely.
F equals ma.
So now I'm not talking about the ball moving as fast as the paperclip. I'm talking about the paperclip moving way faster than the ball. You're going
Now what you
direction.
have to understand is when you're in the normal atmosphere and the things are on a table, you've also got other forces acting against it, like friction on the table, friction due to the air, resistance due to the air. If you were to do this in a complete vacuum, you would probably get very different results. But the fact is, none of that debunks gravity. Gravity does as we expect it to do. So if you're going to say gravity isn't real, what evidence do you have that gravity isn't real?
Okay, well here, if gravity is applying the same force on everything, like you're saying it does, right? It applies.
No, it has more force. If the acceleration is the same and there's more mass, that means there's more force. It's applying. It's applying the same acceleration to everything.
So terminal velocity doesn't exist?
Yeah, of course, but that's because of other forces acting. There's an atmosphere which creates friction. And the denser the atmosphere gets, the more friction there is, the more speed. And frictions can create a force, right? And surface area so for instance, if a skydiver is falling down, they reach terminal velocity because the surface area creates enough force in the opposite direction to the acceleration of gravity. Right, because it's creating friction against the air. Let me talk. Right, don't interrupt until I've finished. I'll let you know when you can talk. Okay, as a skydiver is falling, the faster he goes and the closer he gets to the ground, more and more resistance is applied to the surface area because as his speed increases, the resistance against the air gets more and more until the acceleration of gravity is balanced out by the resistance caused by the air acting upon the surface area of the skydiver. That's simple drag physics, okay? So that's what we expect to happen. If you're in a complete vacuum, you do not have terminal velocity.
Oh, can you show that?
Yeah, things don't reach terminal velocity in a vacuum.
I've never seen a vacuum that tall. Can you show that? I tried to look for it.
Yeah, well, there's no reason to have terminal velocity because there's no force acting in the other way. What force in a vacuum would cause something to stop the acceleration?
There's nothing stopping the acceleration in
apart from the air resistance, of course, acting on the surface area of the skydiver. Are you telling me that when you move your hand through the air, you can't feel the air on your hand?
There's no against my hand. There's my hand pushing against the air. There's no force against it. That's my force.
You're feeling resistance, right? And if you stick your hand out of a car window, does your hand not get pushed back by the air?
Because that's wind. Wind is not blowing up.
Excuse me, are you saying that if you're traveling 60 miles an hour in somewhere with no wind, are you saying that if you travel 60 miles an hour in somewhere with no wind, your hand won't get blown back as you stick it out the window?
Can I talk?
I asked a specific question. Answer the question.
Mute yourself. I'm muting myself. You mute yourself.
Answer the question that I've just asked.
I'm going to mute yourself.
No. Just answer the question.
Are you going to shut the fuck up then?
Answer the question specifically.
Are you going to shut the fuck up then?
Answer the question.
Look, here's the answer, bro. If you're going to say that the wind is a force because you can put your hand out of a window and feel that, fine. Wind is a force. I don't disagree at all there. But
didn't say wind was a force. You're strawmanning me.
Fuck up, dude. No wind blowing up against the skydiver. There's only the skydiver.
You are strawmanning me. I never said wind is a force.
Well, it doesn't matter. It is. It is. So.
But that's not what I said. So why are you talking about that? That's not what I said.
What is that? What is that going across your hand? Is that not moving air? Is that not hair?
It's your hand moving through the air. It is not wind.
Is it going to push your hand back? Is it going to push your hand back without you? It doesn't push your hand back. If you stick right.
If you are traveling along the motorway at 60 miles an hour on a day where there is no wind at all, and you stick your hand out of the window, your hand is still going to be forced to the back. Yes or no?
Yes, it will be for you. Yes, you're meeting resistance.
Why is that? There's no wind. Why is that happening?
There is wind. You're creating wind.
No, you're not creating wind. Wind is the atmosphere moving. You're not creating wind. Your hand is simply moving through the atmosphere, causing friction and resistance, a force acting in the opposite direction to the direction your hand is traveling. That's why your hand is pushed backwards. In the same way, as a skydiver falls through the atmosphere, the surface area of the skydiver creates a resistance, friction, a force in the opposite direction. The amount of surface area will determine what the terminal velocity is. It's very, very simple. The same way that if I was to drop a balled up bit of paper and a bit of paper that wasn't balled up, they're both the same. Density hasn't changed or anything. The only thing that's changed in this case is the surface area, right? The ball would drop straight down. The paper will float because it's being resisted by the air, not wind. Fuck me. Right. I didn't realize that you had got stupider.
Resistant. It's not. It's... Either way.
Go on. Tell me resistance isn't a force. I dare you.
No, I didn't say that. But I'm saying gravity is supposed to be an exponentially increasing force as you get to the creator of it, right? The center of the Earth is supposed to be
by how much? Could you tell me what the predictions of gravity is?
Exponentially greater.
No, it's not exponentially. More. That's not correct.
Well, it is exponentially. Like
no, it's not exponentially. It's proportional.
The farther away from a planet,
exponentially is not the correct word. It is proportional.
No, the farther away I get from a planet, supposedly, the less gravity it shows on me.
Yes, right? Because it is proportional. Right. Obviously, I need to explain to you what the force of gravity is before you carry on, right? So the force due to gravity, right, is proportional to the masses of the two objects and inversely proportional to the distance between the centers of the two objects. That is how you calculate gravity. So inversely proportional for distance, inversely proportional for distance, proportional for mass. Not exponential, proportional.
Proportional when you're talking about it like that, but when you're talking about getting closer, it increases exponentially.
No, it increases proportionally, not exponentially. That is not the correct word.
Does it not make or have more of an effect on you the closer you get?
Yes, proportionally, not exponentially.
That's exponential. That's exponential.
No, proportionally, not exponentially.
It's both, actually.
No, it's really not. You do not know what the words mean.
Attracting, that's proportional. But if you're talking about it, any object coming to it, that's exponential.
No, it is proportional, not exponential. I don't know if I have to say it many more times to get it through your thick head. It is proportional, not exponential. Okay? So please do not strawman gravity and think that that debunks it. You need to understand something first. And to understand it, you would at least have to tell me Newton's law of gravitational attraction. Can you do that?
Wait, do what?
Can you tell me Newton's law of universal gravitational attraction?
Mass attracts mass.
No. What's the actual law? It's mathematical.
No, I can't tell you the mathematical law.
So why are you trying to debunk gravity if you don't even know what it is?
I don't have to understand that to understand.
Yes, you absolutely do. If you do not even understand that Fg equals gm1 m2 over r squared, then you are not qualified to be discussing gravity.
How come fish aren't pinned to the bottom of the ocean?
Because of buoyancy.
Yeah, because of buoyancy. But
yes, which is a prediction of gravity, yes, as we explained.
Does gravity work in water?
Of course it does. That's why there's buoyancy.
So the more mass something has, the more down it should be, right? The lower it should be.
Yeah, but also the lower you go in the water, the more buoyant force there is applied because of the density of the medium, which changes. As I explained to you, the buoyant force is rho GV. Rho being the density of the medium, G being gravitational acceleration, V being the volume displaced of the medium that you're in, right? So the lower you go down in the water, the denser it gets, the more buoyant force that is applied, meaning that a lot of fish simply can't go down that far because the air in the lungs creates a buoyant force which keeps them at a relative depth.
I don't know about that, but that's how you get density.
I don't know about that. That should be your mating call.
That's density. You just explained how you get the density of an object. You put it in water and you check the distance.
Yeah, but there's a very important part in that, which is G for the acceleration due to gravity.
You're missing D. Where's D?
Rho stands for the density of the medium. Okay?
You don't. The density is found by displacing the water.
Oh my goodness, you don't know what I mean. Right.
You find the density.
Hey,
you can the gravity of something, but that's not how much.
Should we see if there's any questions for you in the chat?
Sure.
And then I've got a question for you that, in fact, I'll do my question first. So about a year ago, you contacted me on YouTube. You're like, let's have a debate. And we started talking on Hangouts. And you were due to come for debate. And the day that you were due to come for debate, you instead sent me a message asking me for money.
What?
And I was very confused.
I didn't ask you for money.
Have you not gone back in our Hangouts?
No.
Because I've never understood what that was about. So let me go back into the conversation, and I'll read to you what happened. So it's a little bit back. So let me All right, here we go.
Why the fuck would I ask you for money?
Just get into the right bit.
That'd be more than $50,000. How much did I ask you for?
So, right, 25th of June, 2020, we'd agreed to have a debate, and I messaged you, we all good? About 10 to 8 in the evening here. And you there? Didn't get any response. And then at 10 past 11 my time, I said, yo, Flat, you there? And you responded, yes, I need $65 really bad. I'm so stressed. Can you help me, please? I'll repay you Monday, no bullshit. And I never really understood what that was about. Why did you ask me for money?
I don't know. Fucking show it.
You want me to show it?
Yeah, I want to see that.
Display one.
The only thing I could think of is maybe my fucking girlfriend at the time fucking tried to talk to me or something.
I have to go back up to it now. So, this is our conversation here. Yeah, so here, yo, Flat, you there? And then you responded, yes, I need $65 really bad. And I said, sorry, I can't. Then you're like, fuck, I'm fucked. And then you were like, I'm so confused. And I never really, then you never spoke to me again for ages. That was the last thing you said to me.
I'm pretty sure that that would be my girlfriend at the time getting into my phone, trying to contact me somehow on that. I don't know what the fuck going on with that, but obviously that's not anything like anything else that we've been talking about in there. And there's no reason I would ask you for fucking $65. You're in Scotland, right?
Yeah, I was very confused at the time that you, instead of coming to debate like you'd agreed to, asked me for money.
I did try to do that debate. I've tried to do every debate that we've had. Don't have a set schedule, so it's hard to do shit. But and then yeah, I lost my email. I didn't know, or lost my phone, and I couldn't get into my email, so I couldn't get into my account until I barely looked at my Google, whatever the hell, and saw that old email. I'm like, oh yeah, that's how I can get in.
Okay, so I mean, obviously, I couldn't give you money because you know I have a family and stuff. Well, but if you will go and debate MC2, and I'm pretty sure he can sort you out or something. So you know, just hit up MC2. Now I think he wants you on his new debate channel.
Funny.
All right, so Alison for $2 says, "Flat out hero, why did you bet money that you never had?"
I didn't. If you read the description in that video, you can see clearly that I said I will pay $1,000 a month until I get it paid off, until the end of my life or whatever. So you can see in the description of it that I clearly stated everything that needed to be done.
So you were betting money that you didn't yet have, basically.
Yes, I was betting money that I would be paying. Yeah.
And how much of that have you paid so far?
What was that?
How much of that have you paid so far?
Well, I'm waiting for a winning entry. Have you seen?
I mean, there's two that I could point to, but obviously you're gonna. I'll leave that conversation for MC2.
You have read the description, haven't you?
Yeah, I mean, I've gone back through all of the videos, and according to your specific words, the challenges were met.
It's viable? Who proved that it's viable? Who did that?
Well, it's the fact that it's done on a pilot's thing that shows where it would be flyable. And here's the thing: if your challenge is to prove that it's flyable, then the onus should fall on you, right?
Well, hold on, no. It's my challenge. No, it's my
And
rules.
in
I
the
say if you
original video to Wolfie, you also didn't say you need to prove it's
create the
flyable.
flight plan and then fly it and prove it. You can either take me on
But
the flight.
in your original video to Wolfie, you didn't say it had to be flyable. You didn't say that.
It doesn't matter. In the original one to Wolfie, I specifically said you have to make a Mercator style projection.
No, you didn't.
Yes, I did.
Well, you said in the style of a Mercator, which is what pilots use, and you were wrong because that's not what pilots use. So why would a pilot use a map that a pilot doesn't use?
Doesn't matter. I said Mercator. You have to use.
Yeah, so you're asking for something that can't be done on the Mercator map because no pilots use the Mercator map.
VFR flight charts are visual. You can create a Mercator with those. Go ahead.
Yeah, but that's not what pilots use. They use actual globe
the most
stuff.
distorted maps we have, everybody. The most distorted map is a road map. The one that you use to go before electronics, before your phone. The ones that the Thomas guide, those flat maps, those ones that are most
local
distorted
distances,
maps
distortions are very small. You're right, but over large distances, they use the globe. Right, anyway. So the next question, Jackalope Herdmaster for $2 says, Flat Out Hero, have you apologized to the tree yet?
What tree?
In our first debate, I said that there's a tree that has spent its entire existence creating oxygen just for you to waste it, and you should go and find it and apologize. Did that happen?
Are you going to be this unprofessional? Why don't you just
no, I'm just reading the questions. I'm literally just reading the questions.
Ask a science question. It's really,
well, I can't pick and choose which questions are asked, can I?
You can. You have eyes, so you know what I mean.
But people have paid for these messages, so it's only fair that I read them all, right?
Well, go ahead, go read them all, but you're not gonna have any intelligent ones, so I can just tell you that.
Eon Dust for $2. Hey, Flat Out Hero, have you paid Wolfie yet? Well, we know he hasn't. Robert Luscombe for $4.99 says.
To meet my challenge.
Yeah, I mean, it has been. $5 says Flerfer has zero research apart from YouTube videos. Well, so far that's what his evidence has been, yes.
And my own, the ones on my channel, the ones that I've proven. Yeah, go ahead.
Yeah, so YouTube. JRock69 for $6.99 Canadian says, I shoot 1,000 meters with my .038 rifle and can show data on how with no wind I have to adjust for Coriolis force or I miss. How do you explain this?
Really? Really? Because in the army you don't have to do that, so you're a liar. And what kind of gun you shoot? Fucking liar.
Actually, I can, over 1,000. When you're 1,000 meters, you're going to have up to an inch deflection.
You do not have to count for Coriolis effect.
Over 1,000 meters, you actually have to, and I can show you sniper rifle adjustment tables to show that.
There's already been bets on you lost.
Sorry?
There's already been challenges on that. You guys lost. There is no.
No, we've literally shown tables for it.
No, if you're gonna take a sniper shot, you don't have to include Coriolis.
Apart from the fact that this sniper says you're wrong, I can show you a sniper on YouTube because that's what you like that says you're wrong, and the sniper adjustment tables that say you are wrong.
Anybody who cares to look into it, go ahead and try to fucking find somebody who actually.
Yeah, that's fine, and I can literally point them straight to the video on YouTube of the guy demonstrating it. And
maybe one.
If all you've got, maybe one. All we need is one to show it works. So your response to that is I get it. Stringer News $5 says the Navy does have weapons that do not lose altitude over many miles of flight. They're called airplanes.
Wait, what? What was that?
The Navy does have weapons that do not lose altitude over many miles of flight. They're called airplanes.
Great. I never said that they don't.
I know, that's just in response to you.
That's another intelligent question.
Being completely wrong about railguns. Tim Tully for $10 says, Flat Out Hero, stumble, bumble, and fumble is not a valid rebuttal to actual evidence.
So where's your evidence?
I've shown you evidence.
No,
you went. I don't understand physics as your answer.
Questions that actually pertain to flat Earth, they're just talking about me. So.
Yeah. Pretty
much what I thought would happen.
Let me just get through a few more, and then we go back to evidence between you and I. Connor Silver has been a member for 11 months. Says, Merry Christmas, FTFE. Thanks for the twin gifts of knowledge and entertainment you provided me for over a year now. Thank you very much, Connor Silver, for your constant support. Same for all of you. And then JRock69 for $2.79 says, Long range rifle expert here, can explain well. That's another one. Connor Silver for $5. Don't think we ever managed to split atoms. Tell that to Hiroshima and Nagasaki. JRock69279 says, I've never seen such an unsmart on a live debate. Right, we'll leave it there. We'll come back to the super chats in a bit. Right.
Trust the government? You trust them?
It's irrelevant to this conversation.
Well, do you trust them?
I haven't had any issues with them personally. They've done quite well for me. I've got no real reason to mistrust them, but it's irrelevant to this conversation.
All government funded information. I don't trust government. So if
that's your problem.
Really?
That's fine.
You trust government? You trust government? Because I got video of you saying you don't trust it.
I trust certain things.
If you don't trust something, you can't trust certain parts of it. If
you
make me not trust you, I'm not going to trust anything about you. And that's just important.
Do I think that governments have always been honest throughout their entire lives? No. Do I think they have the general best interests of the public at heart? Yes, I do.
Yeah, so there you go. So that is
So again, that's relevant to empirical knowledge that can be scientifically backed up.
Well,
anyway, let's go to your next bit of evidence for the Earth being flat and non-rotating. And let's maybe try and make it somewhat specific, like, I don't know, a measurement or something. Do you have anything like that?
Like the lack of measurement of a curve.
Well, no, we have plenty of evidence of measurements of a curve and stuff. I'm asking you if you have measurements of flatness.
What do you have as evidence?
No, I'm asking you for your evidence right now. This is your time to present evidence. So, do you have, for instance, a measurement of flatness?
Sure, the ocean.
But the ocean's definitely not flat.
Well, water finds its level.
Level doesn't mean flat, so that's fine. And that is not a measurement. Do you have a measurement of the Earth being of flatness of the Earth? A measurement. A measurement should have units of measurement, significant digits, and a margin of error analysis for the equipment used. So, do you have a measurement that meets those three criteria?
Sure, but it's a telescope pointed across a bay and seeing the opposite bank and seeing where the water's lapping up against the shore.
Have you got any specific measurements, or are you just going to generalize?
Well, I mean, is the Earth 2,400 miles, 2,499 miles around, or 24,000 miles, 999 miles around? About that.
We know what I'm asking you. If you have measurements of flatness,
I'm trying to agree on it. Do we agree that the Earth is a ball that's about 25,000 miles around?
It's an oblate spheroid, roughly, yes.
Okay, so that's
right.
What the orbit.
But I'm asking if you have measurements of flatness, a specific measurement of the Earth being flat.
Determinable curvature. The ball that size will have determinable curvature, correct?
It does, yes. There's plenty of measurements of it.
So now if you apply a calculation, which has been around forever, it's a Pythagorean Theorem. You can.
Sorry, you're using the Pythagorean Theorem to measure. Do you want to explain that? Do you know what Pythagoras' theorem is first? Could you tell me Pythagoras' theorem?
I know you guys got a new Earth calculator that's supposed to.
No. I'm sorry, but you just brought up Pythagoras' theorem. Could you tell me what Pythagoras' theorem is?
No.
Then why did you bring it up?
Because that's how they determine what the original calculation of the.
Can you show me evidence of that claim?
I can't show you anything. You want to look it up? Go ahead.
I mean, you knew we had this bait ranged. So Pythagoras' theorem is a squared plus b squared equals c squared.
It's focusing on the irrelevant part again.
No, I'm telling you what Pythagoras' theorem is, and I'm going to ask you how that relates to the curvature of Earth. So Pythagoras' theorem is a squared plus b squared equals c squared. So could you tell me how that relates to measuring the curve of the Earth, please?
There's a bunch of Pythagoras theorem.
That is Pythagoras' theorem. Pythagoras' theorem is a squared plus b squared equals c squared. That's what it is.
Type in Pythagoras theorem, ball.
Pythagoras' theorem is a squared plus b squared equals c squared.
Has a theorem for a rectangle, has a theorem for every shape. Go ahead and go for ball.
Pythagoras' theorem is a squared plus b squared equals c squared.
Not for a ball.
That is what Pythagoras' theorem is. That's what it is. There is no other Pythagoras' theorem. A squared plus b squared equals c squared is Pythagoras' theorem.
Pythagoras theorem ball.
My goodness, I have to Google your fucking shit for you. Right. Here is Pythagoras' theorem.
Ball.
Pythagoras' theorem equals square root of a squared plus b squared, or a squared plus b squared equals c squared.
Wow.
Pythagoras' theorem is how you calculate the lengths of these sides. So let me type in Pythagoras' theorem ball.
Of a triangle. Yeah. Now
Yeah.
put sphere.
Pythagoras
Now
on a sphere, not Pythagoras' theorem. So Pythagoras' theorem is a squared plus b squared equals c squared. Now, is there a particular formula that you are talking about when you are saying Pythagoras' theorem?
Pythagoras theorem, circle. Yeah.
Yeah. Could you tell me the particular formula that you're trying to reference?
8 inches per mile squared.
And what does that have to do with Earth?
It has to do with the curve of a ball. Or
Says
curve of
who?
a circle. You literally won't type it in.
Says who?
Pythagoras theorem.
Who says that 8
Pythagoras
inches per mile
circle.
squared is anything to do with the curve of the Earth? Who says that?
That's what the Earth curve calculator showed for a long time.
No, it
until they got
doesn't.
the new one. Even with the new one, we can agree on it being whatever. There's going to be a curve. Now, show me what
which
the
is
curve would
measurable,
be.
and it's been measured, yeah. So anyway,
Okay, no, show me
you have
what the curve
deviated
would
from me
be.
asking you for measurements of flatness, specifically a measurement of the Earth being flat. If you don't have that, you can just say, no, I don't have that measurement.
No, I don't have that measurement. But
Right, do you know why you don't have that measurement? Because none exist.
well,
Right,
if you have
how
that
about
measurement,
this,
then
right?
put it to the
As
test.
it's
You
your
have
time to give evidence, right? Do you have
Like
evidence
we-
of the Earth not rotating, like a measurement of stillness?
Yeah.
Come on. Oh, cool. Remember that measurements have to have units of measurement, significant digits.
The
Wait.
The pendulum you just brought up, it doesn't start without being pushed.
And it shouldn't, according to physics, because conservation of
No.
momentum and gravity are
Physics,
things.
according to physics, if it's going to affect it, it's going to affect it no matter what.
Could you please tell me which part of physics says that?
Sure. If a force is applied upon an object, the object is going to, if it's going to be affected by it, you will see it affected.
And it is affected by it because Coriolis force affects freely moving objects. Listen. Coriolis force affects freely moving objects, not things that are still. You are currently strawmanning physics in general to try and win a point that you cannot. So would you like to present a measurement of stillness?
Yeah. The ball not moving without being
That's
pushed.
not a measurement of stillness because we do not expect it to move according to physics. Conservation of momentum. Listen to these two. Like, conservation of momentum and gravity exist. They will stop the pendulum moving on its own because that is not what we expect to happen. Once the pendulum is swinging, which it does due to gravity and inertia, it goes backwards and forwards because gravity is pulling it down, inertia is keeping it moving, and there's the force of the string that is attached to whatever gimbal or pivot point, right? Once it is moving, you can then see the measurable force applied by Coriolis. So we do not expect it to move on its own, therefore it is not a measurement.
Anybody with a brain would, because
No,
if it's going to move,
anybody that knows physics says it wouldn't.
No. See, now look. If it's going to move...
Right, find me one person that in physics that disagrees.
And it will move. Put a pendulum on anything moving and it will move. You can't put a pendulum still on anything moving. Can't do it.
The pendulum is rotating with the Earth.
A pendulum will rotate when it's rotating.
The pendulum, the pivot point...
Will not...
Listen. The pendulum... Don't talk. The pendulum, the pivot point, the string, the entire apparatus is rotating with the Earth at the same rate. There is no reason it would move on its own because conservation of momentum and Newton's first and second laws of motion, they say it should not move on its own. Unless you can debunk all of Newton's laws of motion, you are completely wrong. You are strawmanning physics, and you do not have a measurement of stillness. I am now going to present to you a second measurement of rotation of the Earth, and you can try and debunk this one. And let me say before I do that this measurement of the rotation of the Earth matches the one that the gentleman physicist got. So, enjoy.
If the Earth is spinning at one rotation every 24 hours, that means that every hour it has to turn 15 degrees. And if the gyroscope is mounted anywhere on Earth, it's going to drift. In today's 21st century navigation systems, they're using what's called a ring laser gyroscope. it was extremely precise. If we could
Salami.
simply get one of these ring laser gyroscopes, we would be able to prove once and for all that there is no rotation to the Earth. One of the people in the community actually purchased one for $20,000. But what we found is when we turned on that gyroscope, we found that we were picking up a drift.
What kind of drift, Bob?
A 15-degree-per-hour drift.
Interesting. Thanks for that, Bob. So, what we saw there from Bob Nadell, famous flat earther, is using an interferometric fiber optic gyroscope, utilizing the Sagnac effect to measure the rotation of the Earth, matching the predictions of what you should pick up with an interferometric fiber optic gyroscope, which also matches the measurements that I presented to you by the gentleman physicist. Would you like to now debunk both of them and explain how they both get the same measurement?
I never saw them that they got the same measurement.
They did.
He just said he did. I didn't see it. See that.
He measured 15.04 degrees, and you can find the data for that on globebusters.com.
Let's see it.
Yep, you can find the data for it on globebusters.com. But the thing is, it's what every single interferometric fiber optic gyroscope in the world registers. And in fact, I have footage of that gyroscope registering that.
Okay.
You can find it on my most popular video on my channel, Flat Earther Proves the Earth Rotates Twice, starring Bob Nadell. It's got about 220,000 views and has footage of Bob Nadell turning on his gyroscope in front of Nathan Thompson and watching it register a 15.04 degrees per hour drift, which matches what the gentleman physicist says. There's the evidence. If you'd like to go and watch it in your own time, that's absolutely fine. Now please explain how measurements from a fiber optic gyroscope match that from a swinging pendulum.
I have no explanation. It doesn't.
I do. I have an explanation. It's because the Earth's rotating, and that's what we expect to happen.
Well, we expect to. If we're seeing the force applied on objects, we expect to feel the force.
What you just said was, I do not understand physics.
It doesn't matter about understanding.
So let me ask you, where did you study physics?
It affects the object.
So where exactly did you study physics? Just out of interest, where did you get your qualifications in physics to be able to debunk all of physics? Just out of interest.
You don't need any. You don't need any.
Right. So you think you are smarter than every physicist in the world?
Nope. Not at all.
You are currently disagreeing with every physicist in the world.
Okay.
So you are saying that you know better than every physicist in the world.
I'm saying that they were taught to believe things that are fucking.
No, physicists don't do that. Physicists experiment and verify. So just once again, do you think you know better than every physicist in the world?
Literally verified it. They said that you have to fucking start it, and it will not continue to go. If it's a
of course, it doesn't continue to go because gravity and friction are things. You don't expect it to keep going. But what you do expect is to see a drift which corresponds to your latitude on Earth, because the Earth is rotating.
If you think so, fine.
No, I don't think so. Physics says so.
Good.
Let me check. Hold on. Hi, physics. Hey, how you doing? So if you've got a swinging pendulum, right? In fact, don't worry about swinging. If you've just got a pendulum on its own on a rotating Earth, do you expect the pendulum to just start swinging on its... Oh, fucking hell. No, I'm sorry. No, yeah, I know it's a stupid question. My bad. Sorry. I asked physics and it said no. Sorry about that. Physics in general disagrees with you.
I don't mock you on my channel. I don't fucking care about you, honestly. Like I don't have any reason to mock you. And if you're gonna try to mock me, you can do that.
It's very easy to mock you. I mean, in fact, you kind of do it yourself with the things that you say, like the sun is a burning ball of gas. Oh, he's ran away. Rage quit. Oh, I was going to ask him the rest of the questions in Super Chat. That was a fun little rage quit he just did. I'm not going to mock you on my channel. Of course you are. You're a flat earther. Oh, what a little baby. I don't like that I don't understand physics and he's making fun of me, so I'm gonna run away. Pythagoras' theorem is a measurement of the Earth being flat. Brilliant. Did he literally said it. Can you give me a measurement of Earth being flat? Yeah, water's level. Fuck's sake. I'm gonna bring Toon in. Give me 1 sec. I've told Fat Out Here to come back. I'm gonna send Toon a link. Tell him the stupid that's just been said. My goodness. Siggy Sigwald for 500 ARS. Does he have any other argument besides I'm dumb? No, not really. That's all Flat Earth ever has. Excuse me. Oh. And Toon's just coming in. Hey Toon, how you doing, dude?
I'm good.
I made him rage quit.
I literally just got here.
Oh my god, you won't believe the dumb he's been saying. He actually doubled down on the sun being a burning ball of gas, and we can't have that because there's no oxygen in space.
Oh my gosh.
Tried to debunk Foucault's pendulum by saying, well, it doesn't swing on its own, therefore you're wrong. So I asked him for a measurement of the Earth being flat, and he said water's level.
Oh my gosh. Just shoots himself in the foot.
Oh my god. Oh my god. Oh my god.
So 3 years ago, he was ahead of his time and stupid.
Yeah.
Right? None of the other flat earthers were as stupid as he was 3 years ago. And now he's back, who knows, for 10 minutes or so. And I'm thinking, oh, he's back. Well, tell you what, the flat earthers have gotten stupider. They caught up with him, but no. He's 3 years ahead of them still.
He says, because we can see shapes on the moon, but you can't make out mountain ranges from the ISS, therefore it's all a lie.
Oh, yeah, he used that same dumb thing last time.
I know. He's still stuck on that from 3 years ago.
Oh, yes. Just... No clue.
When he said, oh, gravity's not real, and I can debunk that right now. And what was it he said? If I have a butterfly underneath an elephant, is the elephant still being affected by gravity?
What?
Yeah,
Did he have an aneurysm?
I don't know.
You'd think he'd know if he had an aneurysm and he would say something.
He says, messaging me, he says, hit me up when you aren't just appealing to idiots and you actually want to have a discussion. Well, I was trying, but literally every time I spoke, he interrupted me. I'm not playing into the bullshit. I said what I needed to, and people can choose to look or not. It's up to them. I'm not sitting and taking your disrespect. He also insisted that railguns fire straight, and when I showed him the military stuff showing that it doesn't, he still said, no, you're wrong.
He had a bucket of denial for that?
Yeah.
Oh,
just come back, coward. Toon is here. Oh my god, so much stupid. So he provided more than I could ever have wanted.
Was he on screen?
No, he was in someone else's house and didn't want to be.
I mean, good for everybody because their eyes, because you got to pour bleach in your eyes afterwards, and it's just it's not easy. It's not fun to pour bleach in your eyes.
And you remember how, like a year ago, when he wanted to debate me, and I showed you that he instead sent me a message saying that he needed money.
Yes.
He's now saying that his girlfriend stole his phone and was asking for that.
His well, hold on a second. There's a few things wrong with that. Did you say that he has a girlfriend?
Well, he said he had a girlfriend.
Okay, so now did he mention that he has to blow her up? Or did he opt for the one that's not a blow-up version? I write anti-spam software. I know which versions he could have. No, they're more expensive.
And then when I asked him for measurements of the Earth being flat, he then said, "Well, Pythagoras' theorem." So I asked him.
That's a measurement to him.
Yeah, I asked him what Pythagoras' theorem is, and he says he's got no idea. And then
Of course he doesn't.
Pythagoras' theorem is a squared plus b squared equals c squared. And he went, "No, it's not."
He said, "No, it's not to that." the guy,
it couldn't have been better. Like, so coming up in the new year, I'm increasing the output of videos on my channel. I'm getting a couple people to help, and one thing I want to do is remaster some of my old videos, right?
Yeah.
And starting with the first ever episode of Flerfs for Idiots I did, which was Flat Out Hero. And he's just given me so much extra stuff to put into that remaster.
You don't have to remaster the old one. There's new content.
But I want to go over the stuff that you said in that original one to start with as well.
I suppose.
Oh my God, Toon. That literally every time I started speaking, he would just start.
Well, I mean, he hasn't had anything to say for a while.
Oh my goodness.
Oh, did he? What's he been doing since?
He says he has a job, but I don't know if giving hand jobs in men's bathrooms is considered a job. But
so all right, so hold on a second to return to this thing that because after the part where you said everything after you said he had a girlfriend, I didn't hear because
I know
there's just a hard stop in my brain. So say that sentence again, and I'll try to keep listening after.
I don't want to destroy any more of your brain cells, honestly.
Hold on. I'm prepared.
Tab.
Right, go ahead.
Yeah. Pendulum. Oh my God. He's got a girlfriend that stole his phone to ask me for money, and he's got a job.
His girlfriend asked you for money
on his Hangouts account.
On his phone.
In the middle of us talking to each other about him coming for a debate.
Yeah.
Yeah, he just randomly sent me a message that says, "Hey, I'm fucked. Can I have $65?" See, what I've got a theory as to what happened was he was in two conversations, right? One with me and one with his friend or something, or his drug dealer, who knows. And he desperately needed that $65, otherwise he was getting his kneecaps broken for not paying his bill.
Yes. Because they don't just give meth away. Right? I mean, I don't know. I have no experience with that myself, but I'm pretty sure you got to pay for it.
Not the first time. That's how they get you.
I suppose, yes. Mr. Berger, first name Dick. He's like, please tell me you at least replace the cans of tabs every once in a while. Why? Why do you need to?
No, tab just refills. That's what it does, right?
It's a never-ending supply. NASA sends it to me every month. Yeah,
you know how Spider-Man, at least the Tobey Maguire version, he made in his body, he made the web tune actually has a NASA implant that as he holds the can, it just fills it up. That's what he creates in his body is just tab. Yeah. So I've got a vote going, and the vote says who should get the $100,000 from Flat Out Heroes challenge. Flat Out Hero, no one won, 6%. Wolfie 60-20.
Who would answer that?
I know. Wolfie 60-20 to 60-20 should fly away with it, 39%. But drinks are on MC Toon for 55%.
Even Wolfie said I won.
Yeah, I know. But he still says that no one completed his challenge because he asked for it to be done on a Mercator map, which of course would be impossible.
Well, he never said Mercator map, so he's just lying.
Well, I've gone back to his original video to Wolfie, and he does say, "Oh, do it on a Mercator style map," but I don't think he knows what that means.
No, he doesn't.
No, pilots don't use that. So I mean,
it's possible that a pilot could use any particular type of map as long as they know how to deal with the errors introduced by projection. But it's
Oh, hello, Bob the Science Guy. How you doing, my friend? Congratulations on measuring the curvature of Earth recently. That was quite good. So, have you been keeping up to date with the sextant stupidity?
Yeah, they got their butt kicked on triangulation.
Yeah.
They got their butt kicked because it's trilateration.
Yeah.
They got their butt kicked on the horizon dip, right?
Yeah, yeah.
Because first they didn't understand that, and now they just say you can't have a curved adjacent,
which is stupid because I mean, number one, you don't even have to use the horizon with a sextant, and in fact, when I was on the bridge navigating, like everyone gets their time to do it, and most of the time you don't use the horizon. In front of your sextant on the bridge, you've actually got a little mirror on a gimbal, which is always level, right? And what you sight against is the reflection of the thing in that mirror, and then just half it. You know, so it's most
reflection
of the thing you're trying to get the angle to, right? So,
yeah, you match it both in the sextant and in the mirror.
Yeah. So then that, because the angle of incidence is always the same, that means all you have to do is half the result, and you get what you're looking for. So, in fact, the majority of the time, at least in my experience, and I used sextants even before I joined the Navy. You know, I went to like sailing schools and stuff, and you know, had fun sailing and learned to use sextants. You know, I would class myself as a subject matter expert on a sextant. You know, and listening to their stupid has been incredible.
Let's be honest, though, the ANT part that you didn't hear. You were just there for the first three letters.
Yeah, I turned up. I was like, "Where's the sext?" And they went, "Tunt." Sorry, what'd you call me? And, I mean,
continue. Sorry.
The curved adjacent thing is stupid because they're trying to say, oh, well, because the Earth's curved, you can't have that adjacent. Well, you don't use like the surface of the Earth to sight anything. That's not what you use. It's all imaginary lines, right?
I drew it last night.
Yeah. And there's no
curved lines that you're using there.
So it's absolutely ridiculous.
Come on, flatties, grow up.
And Mitchell knows that I'm going to be making a sextant video, but I'm taking my time because, number one, I like to produce really good quality videos with like fancy graphics and stuff, but I'm letting them get all of their stupid out before I do mine, so that I can just come in and absolutely fucking destroy it. And I've arranged an interview with a guy who runs a sailing school out of Edinburgh, and he teaches to use the sextant. You know, so I'm going to interview in the emails. I was like, look, flat earthers are saying this, and he was like, what? When I'm teaching people about it, I explain how it relates to the globe. So I'm going to interview him as part of my video. You know, literally someone who teaches people to use the sextant as a living. And if they want to argue with the actual experts, it just comes down to personal incredulity at that point, right?
Yeah. Last night I had a professor that teaches surveying on my show, and in the channel was in the live chat was one of Austin Whitsit's clones who said,
"He's so scared of me."
Who said that he did not know what he was talking about.
Yeah,
a professor at a university.
Yeah,
who teaches surveying.
Just like speaking to Flat Out Hero just now, he was like, I asked if he's smarter than every physicist on the world. And he's like, well, no, of course not. I was like, but you're currently disagreeing with every physicist in the world about how a pendulum functions. Well, they just don't know what they're talking about.
Oh, so he does think he's smarter.
Yeah. So he thinks he knows better than every single person in the world that's ever studied physics. Blows my mind, honestly.
And that's the peak of Dunning-Kruger.
And so they're using a sextant, which is literally a globe tool, to try and debunk the globe, which is dumb. But then did you see Mitchell's video? I think it was either yesterday or the day before. And the title of the video...
I think I saw that. The title. Not the video.
Sunsets debunk the globe.
Oh my gosh.
Things that...
It's impossible. Due to perspective. Perspective demands that the sun could never set. But none of them can do the math.
Oh no, none of them can do math.
They just say it's fake.
Right, no, it was sunsets and star trails debunk the globe. Like two things that are literally only possible because of the globe.
It's almost like he's a Poe. Like you take the thing that defeats you the most, switch it around and declare that it disproves the other thing, and not actually try to support your claim.
And in his video today,
Karen B a year ago did equinoxes disprove the globe, and then she went over. She actually explained why equinoxes work on the globe, did nothing to explain for flat Earth. Yeah. Therefore, that's all she had.
Yeah, his video today was a mirror from RV Truth.
Oh, he just mirrored Russian vids?
Yeah. Best flat Earth evidence: water.
Okay.
They're getting
and they do that because the easily swayed people, the people that are not very smart, you can just say water's flat. They say, like, oh yes, and then just like zombies, they just start repeating that mantra.
Yeah. So I've said to flat earthers, if they can show me one time ever where water's flat, I'll delete my channel. And then they show me an ocean. I was like, oh, right. So the oceans have tides.
There's waves. There's tides.
Yeah. Tides show that oceans aren't flat. And then he showed me a glass of water. So I zoomed in on the side where it's got the water
the meniscus going up the edge.
And I'm like, show me a time when water's flat. And he can't. You literally can't show a time when water's flat because it never is. Lakes have tides. Swimming pools that have water tension and meniscus at the side and probably a very small tide and little wave. Water's literally never flat. It's made up of round fucking... Right, if they're saying that water's flat, then they're saying round things can be flat. So does that mean that the Earth can be both flat and round?
It is locally approximately flat.
Yeah, locally approximately
but
flat.
That's it.
Not actually when you measure it.
Because we can do calculus, we can understand that. But there's no Flerfer that can do calculus. So they don't understand, local approximations.
No, they don't. They don't. You could have finished that sentence with "I don't." They don't understand, and stopped there.
Very true.
That was one of the funnest debates I've had this year. He genuinely has got dumber. So
he is leading. He's leading the charge.
Yeah, and he was the first person I ever debated.
That's why we started talking.
Yeah, because you told me off for being so mean to him.
Yeah.
I did watch that video back a few months ago, and I cringed watching it and nearly deleted it from my channel. But I want people to see how I've progressed. I'm still an angry cunt, but
But in a polite way.
Sometimes. I did call him a few names today.
Certainly well earned. I could not argue with that.
Yeah. Bev's putting out some spectacular stupid on Twitter at the moment.
Oh yes. He's lonely. He hasn't had enough negative attention.
He still talks about me at least 4 or 5 times a day whilst having me blocked, which is nice.
Yes.
And
he refers to you often.
Yes. And then I love to show that clip of me asking him, is non-Euclidean geometry a branch of maths? And then after a 10-second break, he goes, level. But Geist View showing in the picture of the sphere, the foam sphere with the rivets put in it, right? And he's like, which one of these is higher? And he just drew marks on the screen saying that one's high. He thinks elevation is curve.
Yeah, all of them do. The Bolivian salt flats, they're like,
yeah,
they pull that up. They're like, the elevation didn't change more than a certain mother. It did, of course. They're self-defeating because it did change. And and they don't have a reason for why it changed its gravity. But they can't explain that because they deny gravity. But in the very measurement document that they talk about, it says it's referenced to WGS 84, which is an ellipsoid.
Yes. Right, so some of the chat is saying that you should not send the guy from last night to me.
No, he doesn't deserve anywhere except for a padded room.
That Alex Morales guy.
Alex Morales, yes.
Morales, yeah. I think I've had him on once and he just swore at me a bunch and then left.
That's all he has.
Yeah.
He is worse than Jason.
Oh, God. What?
Believe it or not, he's worse than Jason.
I saw him come on and complain to you about you putting his picture on the thumbnail, which you got from his publicly open Facebook profile.
Yes.
Yeah. You know, there's settings where you can stop that happening.
Yeah, you delete your Facebook account. Or you don't upload your picture.
Yeah.
Yeah. Or set it to private. So I've done over 200 debates about somewhere in that neighborhood. And it's a normal thing that I do. And nobody's ever had a problem with it. And he blew up as if it was the worst thing ever.
Yeah. And then he couldn't sit, and then just kind of swore at you for a bit. And then that was it.
Yeah. Well, so I sent him the Zoom link before the show started, which he didn't join. Then he spent the next half an hour saying that I was scared of him.
Whilst you're waiting for him to join.
While I'm waiting for him to join, yep. So then finally, I went and I called him on Discord. He didn't answer. Because he wanted to do it on Discord, where I couldn't have it on YouTube. Which I, of course, can have on YouTube.
Why does he think he can't have Discord on YouTube?
He's a flerf. He doesn't understand simple things.
Yeah, right, of course.
And then finally he came back and we talked, and I had told him that I won't let him use racial slurs. He immediately used a racial slur, ended it. That's it.
Oh, they haven't got any better, have they?
No, they've gotten dumber. They have.
I'm 600 debates in, and I can actually count on my fingers the amount of polite flerfs I've had conversations with.
There's a few.
Yeah.
Someone
in the chat was saying that how you destroyed Rachel in the debate you had with her. I know I was producing that, and MC Toon did fantastically.
I've sent a couple. I have a friendly relationship with Rachel. I sent her a couple things of feedback. Like I analyzed the paper where she said the moon glows.
Yeah.
It's gamma rays and X-rays. We can't see them.
Yeah.
With our eyes. It's very low quantities of it. So even if it was visible light, it wouldn't be something that our eyes could pick up.
No.
None of it supports. And in the debate, because I hadn't read it at the time, I said, I don't think it supports what you want it to support. She's like, oh, well, I think it might do. It might.
But what they do is they find these papers and then they just Control F and look for the words they want, and then take that one sentence and think it says what they want it to. But in the same way, I would have asked her, well, what if I use like an infrared scanner and look at something that is hot, and you can see on it's glowing on there, but when I'm looking at it with my eyes, I can't. Is that creating its own light? No, it's not. It's emitting infrared radiation.
Our eyes reach out to grab light. Some of them think that.
Oh, yeah. No,
like you just don't know how your eyes work.
Right then.
Let's talk about who doesn't know how eyes work.
Light just apparently is there, and our eyes reach out and grab it.
They go grab. They can only grab so far out.
Oh my god.
So,
right.
and then the other thing, she talked about the linear approximation.
Yeah, that's just a mathematical function.
She thought that the linear approximation was Newtonian gravity. She made this
she sent that
equivalency because she doesn't know enough algebra to know what a linear approximation is.
I sent her that document from your website, or the few documents about relativity breaking down to Newtonian gravity.
Newtonian,
right?
yeah.
And that's where she got that from. And I tried explaining to her that no, that's not what linear approximation. Linear approximation is a mathematical function about converting from one way to another. You know, that's not. And she then went and said the same thing to you. So,
oh my gosh. And I know why. It's because the name of the chapter is linearized gravitation. Yeah, that's the name of the chapter.
They take words.
So she thought because it had one of the same words in it, it was the same thing. So I sent her a very nice explanation for how that works and what it's talking about, but no response. She hasn't responded to me.
No, she hasn't really made any response since you and I have ruined her in debate.
I hope she's contemplating.
I'd like to think that she is, but I've had that hope with Rachie before. I think Creeping Warrior has his talons too deep in.
Yeah.
So I'm going to read the rest of my super chats now and then go to bed because it's coming up for 3:30 in the morning here.
Oh, sounds good. I'm going to head out.
Well, thank you for coming on.
But if you do talk to Flat Out Hero, tell him that I think he's scared to debate me.
I will absolutely say that because, you know, his ego is... We know you're watching Flat Out Hero and you're scared to debate MC2, aren't you?
Yeah, you should be.
Yeah.
Anyway, did I say... I didn't mean... No, I didn't say that. I would not say that.
Thanks for coming on, dude. And we'll speak to you soon.
All right, bye.
Bye. MC2 is one of my favourite people on this planet. He's such a nice dude. If you're not subscribed to him, then you're missing out. He's a better debater than I could ever be. Because, you know, he's calm. There's a reason I put my debates in quotation marks, guys. You should know that by now. Lord of Luminous Poo for $5. Yesterday I saw a woman get a nipple pierced right in front of me. I guess that proves I'm a bad type. Don't do that. Fuck you, Chew. $5. Asking Flat Out Hero not to interrupt you is like asking a dog not to bark in a house where the doorbell is sorted out. Yeah, he couldn't stop it. He literally could not shut the fuck up. Rudy Questing, $5. Has this Nong not flown before? At 2,000 feet, you can easily make out roads from that height. Yeah. Maths means nothing to these people. You show them the maths, talk them through it, and they just go, nuh-uh. Lord Luminous Poo for $2 says, I have no idea, but it's not that. For fuck's sake, yeah. Fuck you too, $5. Frosty the Strawman. Lord Luminous Poo for $2, and I've just skipped. Your misunderstanding is not our fault. You should study. They can't do that. Aaron Reese, $5. FTFE, if you take a ball bearing made of forged iron versus one made of slag iron, the forged one will move faster due to greater density as with gravity. Yeah, they just don't understand. Teamster for Life, $5. Flat out, if you had a 10-pound bowling ball and a 3-pound gallon of milk, the same distance from a magnet, which would have greater magnetic force? If the milk does, don't drink it. Lord Luminous Poo for $2 says he can't even word. Yes, exponential versus proportional. That was fun. Connell Silver for $5. Proportional 2, 4, 6, 8, 10, 12. Exponential 2, 4, 8, 16, 32, 64. Yeah. Numbers confuse him, as I'm sure does tying shoelaces. Johnny Marr, who's been a member for 11 months, says, Flat Out Hero, why is there a circular shadow on the moon? I should have asked him that. Connell Silver for $5. Flat Out Zero, why do you think a butterfly can hold up an elephant? Yeah, I was going to say, poor fucking butterfly, right? Jesus Christ. Calepsis for $2. Ask him what an exponent is, please. I do not want to blow his mind. Steve6464, $5. Hero, could level and sea level mean the same as height, stage, or point? Yeah, no, he doesn't understand. I mean, I get so sick and tired of explaining that level isn't flat. I don't understand how flat earthers are still saying this, honestly. Well, I do. They're all fucking idiots. B5th for $5 says, go back to the sun being a burning flame in space. That was hilarious. It really was, wasn't it? Never gets funnier. Syed Ahmed 499, FTFE, your opponent is really scared to answer questions and changes the topic. So weird, I know, right? 2022, the return of Lemon Bird. I mean, I can dream. Do you want Lemon Bird, guys? I can get Lemon Bird back. 1 in the chat for yes, I'd like to see a new debate against Lemonbird. 2 in the chat for I can't cope with that. 1 for Lemonbird, 2 for fuck no. Siggy Sigworld for another 500 ARS. Thank you very much. Happy holidays, FTFE and all. Happy holidays to you all as well. Wizard of Frostballs for $5 says, that was a crash and a burn. Flatliner was unprepared for this, as if he could ever be. Ooh, it's kind of split. 1, 2, 1. I think I might put a poll on my on the channel. There's a lot of 2s, but I think 1s have it. String News 1 for $5, but Flerfs can see gamma rays. Chris Keeling for $5. The sun is a massive incandescent gas, a gigantic nuclear furnace, where hydrogen is built into helium at a temperature of millions of degrees. Yeah, it's not gas though, it's plasma. But yes, absolutely. Pat G for $5 says water should put a GPS locator on its level, for crying out loud. And then Wizard of Frostballs for $10. Why has no Flerf tried to fly over the edge of the Earth and taken photos? Because that would destroy their Pancake World fantasy. That's going to be it for tonight, guys, and probably it for before for until after Christmas. I want to say from the bottom of my heart that the support you guys have shown me this year has been insane. My channel still continues to grow. I get like between 500 and 1,000 people watching all my streams. The super chat support and the memberships and patrons, it's insane and constantly blows my mind. And I give you this promise that I will up the rate that I'm putting out content. I've had a few problems this year with being an extra pain and having a bit of mental health problems and some illness. But thanks to the love of my amazing wife, I feel like I've got the strength to go on and push out some more stuff for you guys. Honestly, I could never say thank you enough. I hope all of you have an amazing Christmas, spend some excellent time with your family. Oh, another super chat. String News 1, $5. Happy Christmas, FTFE. Happy Christmas to all of you. I'll be back before the new year with maybe a video or possibly a couple of streams. And until then, remember, stupidity is not a right. Fight the flerf.
Fight the flerf. Fight the flerf. Fight the flerf. Fight the flerf. Fight the flerf. Fight the flerf. Fight the flerf. Fight the flerf. Fight the flerf.
Tepo Sulapoo, I'll get some FTFE bathwater just for you. Need to join my OnlyFans.
Fight the flerf. 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 Fight the flerf.
Good night all. Thank you very much for joining. Share the stream. Aaron Reese for $2. Take care of yourself. Craig will be here. I'll always be here as well.